Alright, here's my data for screencast7 with the 4 different geometric shapes with the hoop disc, the hollow disc, and the sphere. My data here at the bottom, the one on the left is changing the radius and keeping the mass the same on the 4 different geometric shapes, the hoop disc, the hollow disc, and the sphere. As you can see, the values do not change, pertaining to changing just one of the variables with the radius. The values remain constant throughout, meaning that everything is going to cancel except for the value of the square root 4 and the either the disc. You got the 1/2 value is not going to change. The 2/5 value for the sphere is not going to change. So it's basically the square root of 4 divided by 2/5 for the sphere, etc. And the interesting thing I found with this data is that the mass, changing the mass and keeping the radius the same, these two values end up exactly the same. So what that tells me is that both need to change. And here's my moment of inertia values with changing the mass at the top and changing the radius at the bottom. Now if you were to plug these values in to the formula of square root 4 mass times both the heights, height 1 and height 2, over the radius squared plus mass, then you would have a change in the distance. But changing just one of the variables does not change the values whatsoever. And the graph, the top graph, is the change in mass. Shows how the distance doesn't change. Oh man, my screen's kicked in. Alright, now here's the one on the bottom. The graph on the bottom is changing the radius. Radius on the bottom for my x values and the distance of my y values. You can see how those values are exactly the same when they're plotted on the graph. That was a pretty neat screencast. Basically, mathematically it showed you that it doesn't change unless you're actually changing the moment of inertia values. Very interesting.